Good. And so in now what we should know is about the electric field. Basically, electric field, before you define the electric field in your class, you're going to talk about the electric force. Because you have to talk about the electric force, electric field, electric potential, those things before we move into the current and the voltage. So basically your final things you're going to learn is electric circuit. Right, so those will be basically you talk in electric potential and the electric current, right? But before we talking about the potential and the current, the physics behind this potential and the current is the electric force and electric field. That's why you start with the electric force. Otherwise, electric force is not able to measure in our laboratory. So we can measure the electric potential and the current only. Even electric field, I'm not able to measure in the instruments we the given, right? So the things you are learning beginning of the class, everything is like background or the basic. You need to learn the electric potential and the current. So now I know that you guys start with the Coulomb's law first. If you have positive and positive charge, these two charges will be repel each other, right? Start distance Q1, Q2. So since both are positive, they will feel like they are repelling each other. Then this has the force F. The magnitude of the force is given by Coulomb's law. That's the magnitude. Direction you need to take from the which particle you are working with. As example, positive will repel and negative will repel. Positive negative will be attract each other. These things you guys know. But this will be K times charge of first particle, charge of second particle, and you're going to divide by the distance to the power 2. This will be the magnitude of the force. Both particles has the same force, right? This is similar to Newton's third law. So you have same force in both particles, but the Coulomb's is talking when there is two charges only. If there are more charges, you need to use the superposition principle. So you're going to solve the problems by using that. So this K, we call it as Coulomb constant, that is 8.9910 to the 9 newtons meter square over Coulomb square. That will be the K. So now again, we are not able to measure this in the laboratory, right? So what we are interested is the potential. So now before that, we need to talk about the electric field. So now if you take the positive charge, we say this is source charge. That's what the particle that produce the electric field. We say charge Q. And then you try to bring a very small charge. We call it as test charge, right? Lowercase q. So now again, this is positive and positive. They definitely will repel each other, right? But the electric field is defining as something that this test charge will feel. As example, test charge will feel, I am pointing outward. I am throwing out from this positive charge because source charge is very strong. That will produce the electric field. Because of that, test charge will going out. So that is, we call it as the electric field. So that feeling, this test charge field, feeling of test charge is the electric field. We usually use the symbol E, right? So now after you learn that, after you realize that, that means this positive charge will create the electric field outward. That will be the electric field from any positive charge. Any charge, any positive charge, it will be pointing outward. This is defined as basically force per unit charge. Now you guys can check in the Coulomb's law. If you write the force and divide by Q, then you will end up with K, Q and the R square. One of the Q will disappear. Units of this will be newtons per Coulomb, right? So now electric field only depend on source charge. So that's the important thing. So only depend on source charge. It doesn't matter what test charge you bring. It is independent of the test charge basically. Right. So now the same way, if you have a negative charge, if you try to bring the test positive charge again to the source charge, these two will attract each other. Because of that, that feeling for the positive charge will be pointing inward to the source charge. So that is the electric field for the negative charge. So after you realize that positive charge has the going out electric field, and negative charge has the incoming electric field. So because of that, so you can define the electric field anywhere you want. This is not the real system. I don't have the positive and negative separately. So usually we have the lot of charges together, right? So now the system we're going to study in the lab is the 2-point charges. So I'm going to write it as dipole. So I hope everybody understand when I say dipole, that means two charges sitting together, right? So now we're going to keep positive terminal and negative terminal, two electrodes basically, right? So now the knowledge you know is positive charge has electric field pointing out and negative charge has electric field incoming electric field. So now if you draw the electric field for this system, it will be something like this. You have electric field starting from positive charge and ending with negative charge. Right, so now on the back also I have electric field, although I cannot draw it. That will be also starting positive and finish with the negative charge. So this will be the electric field for the dipole system. This is what we are going to draw. Again, although we are talking about electric field, there is no measurement I can take. Only thing I can measure is the potential. So the potential you're going to talk in next chapter, I think. So it is not the electric field. After you finish the electric force, electric field, you're going to move into the electric potential. But the important thing is electric field is related to electric potential too. So I'm writing magnitude only. So otherwise there is negative sign. Change of rate of or your delta V over delta X, if you write it in calculus, dV over dx, right? So that means if you know the potential difference, you will be able to calculate the electric field, right? So but if you have equal potentials in any line, equal potentials, we call it as equipotentials, equal potential lines. That means you basically have the same potential throughout the line, right? So those are the lines we are going to draw. After you draw the equipotential lines, you will be able to find the electric field line. So I will explain why you can find it, but let's see how we can draw the equipotential line. So now equipotential means equal line. So we can measure by using the voltmeter in the laboratory. So you take the voltmeter and you're going to measure the voltage around this circle, okay? And then you're going to find few points around that circle which has the same potential, right? So that line we call it as the equipotential. So now we'll say this has 8 voltage, right? Whichever voltage I have, and then I take the my voltmeter again, and I'm going to measure the another voltage line which has maybe 6 voltage, right? And then you take the voltmeter again and measure the next line. So likewise, you're going to measure the voltage around these circles, then you can find those lines. Those lines we call it as the equipotential lines. Okay, this the color green equipotential lines. I'm going to say lines in here. Those are equipotential lines. But the important thing, after you draw that, you will be able to find the electric field lines, because these are always perpendicular to your electric field lines. These points everywhere, they should be 90 degrees with your electric field lines. Then you can draw the electric field lines if you want. Okay. So basically in lab what we're going to observe these equipotential lines for 2 charges, and also we're going to do the same experiment for the plates, electrodes. I don't know why I have that in there. Okay, it will not disappear anyway. So other thing we're going to do is 2 plates. We're going to use the positive electrode which has the charges everywhere on the line, and then we're going to use the negative electrode. So now this is actually later on you guys are going to learn this is a capacitor, so parallel plate capacitor, but in here we are not talking about the capacitor concept. We are just watching how the electric field behave in between these two plates, right? So again you have the same concept, because electric field is starting positive and ending negative. right? Start positive, end in negative. Now you should have, in this case, horizontal electric field line since I have plate vertical. So this will be the E, but it is very special in parallel plates. This E is a constant, inside at least. It is uniform everywhere. But when you come to the corners, you definitely see the winding little bits. But we are not worrying about that because capacitor concept, we're going to use the electric field inside. Right? Those should be just a vertical line. So now in this case, if you draw the equipotential lines, they will be just like this. So this may have potential 10 volt, and next line you may have potential 8 volt, right? Something like that, depending on how many voltage you supply to the your plate. But those dotted lines in the green are the equipotential lines. Again, you have the same concept, they are perpendicular to each other. Okay. Important thing is, if you need to bring the particle through the equipotential lines, you don't have to do the work because you have the same potential. Work is defined. You guys are going to do those in the class. I'm not going to take the time on that. Your work done is defined as charge of the particle times the change of voltage. Since equipotential lines has the change of voltage 0, then your work done will be 0. That means you can bring the particle throughout the equipotential line without doing any work done. So that's the important thing. Okay, so those are the things we're going to learn during the experiment today. Okay, any questions?
No.
Okay, let's move into this setup. Okay, so this will be the experimental setup we have. So now you can the SAC, you can start do the experiment at the same time with me. Okay, and computer you don't want it right now. You can use it later. Yes. What was the question?
No, I was just gonna say it was upside down. And it's not moving.
Don't complain in that side. You need to come to the lab if you want to watch it very carefully. So this is what I'm going to focus into the in-class students. Okay, so it is not upside down. That is the correct direction. Okay.
Yeah.
So now in this setup, the in-class is yes. It's frozen, or maybe that's why they see the upside down. Can you see the resistors? I have it in the top. Or maybe I can close it and open it again. Give me a second. So maybe that's why you see the upside down.
No, it was on the right side when it changed. Oh.
Now when I open it, it will again go back to the other side. That's right. Is that okay now?
Yeah. Thanks.
Okay. Okay, so now in your setup, you have power supply. This is called as the power supply. So we have the knobs in there to connect it to the circuit. And then I have this one, this is called as the voltmeter. Okay, this one we can, can you guys see my voltmeter?
Yeah, we can see now. Thanks.
Okay, so whatever, it's fine. So you just close it, watch that one. Okay, so now you have the voltmeter in here. Voltmeter, we have different usage. Sometimes we use it to measure the current by using left two and the comb. But in this experiment, we are measuring just voltage. So to measure the voltage, we have to use the comb and volt. Basically, we're going to use right two for the setup today. And then we have the table, we call it as electric potential mapping table, that is this one. And now in addition to that, I have the probe. This is the probe we're going to use. We will see how we use it. And now in addition to that, I have 4 envelopes in your table. So those are the templates we're going to use for the different configurations. And so now first thing is we're going to connect the circuit. To connect the circuit, the in-class student, you can turn upside down your table and then unscrew these two middle screws, take it out. You just want to follow it. And then from the envelope, you have called name 2 points. You need to take it out always. That's it. Yeah. And then you're going to take the template, 2 points template, and there are 4 templates. Yes, 2 points, not the template, 2 points one. Yeah, that's right. And you're going to take that, and when you take this one out, you will see the plastic kind of one side. This one is plastic, and this side has the metal, right? So you're going to keep the brown side down and metal side up, and then you're going to screw two screws you take out earlier. So you're going to screw them. Thumbnail is enough, so you don't want to tight it. Just keep it in thumbnail kind of fit. That should be enough. Okay. Now turn it around again and flip it over. And so now this table has 2 knobs here to supply the electricity, and then I have some resistors here. These resistors make it into a different potential lines. Okay. So now you're going to take the red wire, one of red, and then you connect that one end of that to your power supply. You will see on the power supply there are 2 on one side, 4 in other side. So left side has 2. That thread is the one we're going to use, because we're going to use DC constant voltage for this. So you're going to connect red into red. And then other end of the red, you're going to connect into your equipotential board onto the left side. And then take the black one, connect into the power supply black side and to the right side of the equipotential table. And make sure your wires are not on the table, keep them by side. And now again the voltmeter we're going to use is the voltage, right? So I'm going to keep it in here, but you can keep it by side. I need to show them to how to connect this one. So then you take the, you finish that one? Yes. Take the other red wire and you're going to connect that red into volt knob, that is the last one on your voltmeter. And then the other side of this thread we're going to connect into E1 on your field. So I'm going to leave this on the other side because I'm not able to use that in there. And then you have the red one, and take the red one, black one. So red the black one, and that one you're going to connect to the COM of your voltmeter, right? That's the COM is the next to your red one. So connect into the COM, and then you're going to connect this black into the probe. So this is the probe, and you're going to connect into this hole in here. Yes. Okay. So now our circuit is connected. So now only thing is I need to set up the graph paper. I need to provide the graph paper. So now you take one of the graph paper you have and leave that on the landscape direction, and then you're going to keep it in here, and then you have this 2 black kind of bubbles in here. So you're going to push, not the bubbles, close to that, push the table down, then you can insert your graph paper through that 2 bubbles like this. Just push the table on the top. Yeah. Good. You can take it out and push it again. Do it both sides at the same time. Good? Yeah. Okay, so now you have the envelope called the template one. Yeah. And take that template out. Okay. And then you should have kind of 3 holes on single line, these big 3 holes, and top you have 2 small holes. So you're going to put these 2 holes onto these 2 small knobs on your table. Good. Okay, so now we're going to draw the 2 electrodes because we have the on the bottom 2 electrodes, you remember. So that 2 will be this inner circle, inner 2 circles. This one, and just draw the boundaries. You cannot flip it over. What do you mean by flip it over? I don't think it will change the inner 2 circles. Although you flip it, it should be inner circles will be exactly same position, right? Does it change? No, it will not change. So yeah, so it doesn't matter. So you always do the inner 2 circles. After you finish it, so you can take that and leave it inside the template one where you take it. Okay. So now you're going to plug your power cord to the power supply. Good. And now make sure that you have the voltage. Don't on. Did you on it? So you have a voltage knob in there. Check in on the screen because you can see everything on the screen. So make sure that you rotate it all the way counterclockwise. That is off mode basically. Now you're going to switch on your power supply on button. Now you will see the lights, right? And now rotate your knob to check the reading. Here you have DC volts, and check that to the increase it to 10. Usually when it start it will be 0. So you want to increase it into around 10. So not exactly 10, so somewhere around 10. Okay. And so now you have the voltmeter. So voltmeter, you need to switch on it first. There is a switch on button in here. Okay. So now you will see that we're going to measure the DC voltage. That means I should have the volt with the DC line. So that is this side of the corner, right? So rotate your dial to the 20 volt range, 20 volt. Okay, good. So now you're going to leave that on the table. And so now you're going to take the probe. Now I'm going to find the first equipotential lines around my red wire side, right? So now you bring your probe, and probe has the hole, right? That hole should be on top side, top direction. Yeah, because we're going to put the pen to mark the dot. That's right. Okay, so now you insert this, the top part you insert table in between. Good. Yeah. So now we need to find the voltage 0 point. So now when you bring this to the different places, you should see the different voltage. If not, something wrong with the your plate. Do you see the different voltage? Yes. Okay, good. So now bring it closer to the your first electrode, and do you see the positive and negative change? Sometimes it says positive, sometimes it says, okay, good. So now you move in between that number, then you will be able to see the voltage 0. around 0, I mean 0.01 will be fine. Okay, so after you find the 0 point, you take your pen and insert that through the hole and make a dot in there. You're going to find a few points, not a single point. So after you find one point, you make a dot and then move around and then find the another point. Take it around 5 points. The more is better, but I'm going to move into the 5 points because of the time we need to complete the experiment. So second point. Sometimes it will be very hard to find the voltage 0 point for the first equipotential lines, but the others will be easier than that. So if you are not able to find the position on that side, you can always insert your probe in the other side if you need it, but sometimes it is not needed. It is depend on your case. Did you find around 5 points? That should be enough. So now you're going to connect these all the points by connecting line. Make sure it's kind of curved always. If we know that it is around this your electrode, try to connect them together. Oops, my pen is not working. It will make a kind of eye shape when you do it, basically. So that will be your first equipotential line. Good. Okay, so now take out your E1 and put that back into E2. Only that wire. So to E2, that will give you the second equipotential line. Then you're going to find the 0 again around your first circle. And that will be little far away from your electrode always.
Professor,
Yes, what?
your screen is kind of lagging right now.
Okay, so it's just drawing the equipotential lines for each resistor. That's what we are doing. I'm going to refresh the page in a minute.
Okay, thanks.
Okay, so take around 5 points for that. I don't know why this screen is freezing always. It works yes the morning very well. So after you find those lines, you're going to draw the equipotential lines by connecting those dots. I can try one around here. Okay, good. Okay, so let's move into the next one, and you just keep moving until E7. So that's what you're going to do. So now E3. So you cannot draw the big line here because you will not see the zero until somewhere outside. So you can move into the up. Okay, so that has little less curved. Okay, so my one is little tilted. Okay, so you can keep moving. Okay, so to the next one. The E4 will be just usually straight line, but sometimes maybe little curved depending on the voltage you have. If your voltmeter switch off itself, make sure you switch on it again. It has some photo off. Actually, these couple of points are a little off. It's okay. Is that the last one? Okay. Anybody have any questions?
That weren't these supposed to be the potential lines?
That's right. Yes. Those are the
Oh,
equipotential lines which like separate in the middle around 1 centimeter gap.
but it don't very I thought it looked more circular.
Yeah, because I cannot make it circular because this one has the equipotential lines. This as example, these two lines I have two potentials. But if I need to make inner one from this one, then that will be circular. Then, but when it closer to the middle, they will be just vertical. But this setup has the steps. Those are the resistors I can use. Because of that, it will calculate your total voltage evenly to the 7 resistors. Because of that, I can only draw that 7 lines. Okay. If you need to make it more circular, you need to take the in-between reading with my first and the second line. Then that will be more circle, like oval shape.
Okay.
Yeah, but this one has limited lines I can draw. That's the 7 line I can draw. But in real life, you have in-between lines too. It's not only these lines. These are the this is the setup we can use. Good. Okay, good. Okay, so now let's measure the voltage of this each line. So to measure the voltage of each line, what we're going to do is we're going to take this E7 out, and then you're going to connect that directly to the your left side red on red. Right. So now this will be 1 voltage. Now I'm going to measure the voltage with respect to this point, basically, right? That is the first electrode voltage. So now you bring your probes, but before that, make a line horizontal in your hand. So you can think it or you can draw it as you want. I'm going to draw kind of like a straight line, horizontal line, which will connect these two circles. Or you can just think about that line, you don't exactly have to draw it. But sometimes I may forget that which line I use. Because of that, I will keep that line as a guide to take the potential. So now I will bring this one to my first line on that crossing point with the horizontal line. I'm going to measure the voltage at that point. So I have 1.31. I'm going to write that on this one. Somewhere here 1.31 volt. And then you move into the second one, then you're going to measure that voltage, that is 2.17. 2.17.
I'm sorry. Could you repeat the first time? You said the first
I
line
am
was
going to write those numbers on the table in a minute. And the
okay.
third one is 3.41. And then next one is 4.78. And next one is 5.81. And number 6 is 7.15. And number 8 is 7.98. Good. So now we need the voltage of the two electrodes. We supply around 10 volt, but that 10 may not be exist in here because it can reduce due to some resistance through the process. Because of that, you're going to take out the black from the probe and you're going to connect that into the other end of the table. That will give you total voltage of your two terminals. So I have 9.47. You should have something closer to 9. So I'm going to write that number on the top, 9.47 volt. Okay. So now let's move into the table and we'll write those numbers. You can take out this one by pushing the table again down both sides. Take out the graph paper and we're going to write those numbers on the table.
Should I put in the numbers that you have, or should I put in my own?
You're going to put your own numbers. And that's what the thing when you come to the laboratory, right? So that's the important thing. Otherwise, everybody has to use the same numbers without any reason. So the first potential, usually those lines are separated around 1 centimeter for each one. So in that horizontal line, they are separated around 1 centimeter, right? Yeah. So we're going to use the, everybody has the 1 centimeter gap. So we're going to write 1, 2, 3, you can write. Those are the 7 lines I have, and the first line I have voltage 1.31, and second line I have 2.17, and third line I have 3.41 and 0.78, and next one 5.2, last one 7. And this is asking what is the potential difference between charges. That's the value we measured last. Okay, so I will send you guys the picture for the remote student, my diagram. I will post it on the blackboard. And so now let's move into the second part. Did you complete it? Everything is good?
Yes.
Okay. Yeah. And let's move into the next configuration. So now you're going to, you don't want to complete that table. If you complete the Excel sheet, that should be enough. You can copy and paste into your lab manual directly. That's why I put the Excel sheet. So you're going to take out the black from the table and connect that back into the probe again, because we're going to do exactly repeat the same thing for the next configuration. Okay. And then you're going to take the this thread out. That's the your voltmeter one. And then you're going to take these two also out. And so now you're going to flip your table again and unscrew, and you're going to keep the 2.1 on that envelope. You remember that the envelope you used earlier, it says 2 points. Leave that inside that. And now we're going to take the parallel plate envelope, and it has a plate kind of this. Okay, and again brown side down and the plate top, and you're going to screw that onto the table. Flip it, and now make sure that you have the power cable, black one, you're going to connect into the right side, and power cable, red one, you're going to connect into the left side, and then your voltmeter, red one, you're going to connect into E1. Okay, so now we have 10 voltage we already supplied, right? We're going to use that. Usually we have to switch off, but that's fine. So we have 10 volt it's already now. Maybe we can switch off since we're going to use the table. You can switch off the power supply. Okay, and make sure that you rotate your voltage to 0 too, because we don't want the sudden current to pass through the plate. So now we're going to take the template number 2. We need the graph paper before that. Take the template number 2 out and also second graph paper, and you're going to leave that here. Press it. And then you take the template. This one is easy. You have only 2 holes. Leave that on the top, and then you're going to draw your plates. That means this vertical hole you have. Okay, so now leave that on the template number 2 envelope, and then you have on the parallel plate. Okay, so now you can switch on the power supply and give around 10 volt as we used earlier. So now for the parallel plates, we know that our equipotential lines are just vertical lines, right? So it will be easier than the earlier one. So we exactly going to repeat the same thing. So you go the probe and find the 0 voltage point closer to your left one, and then you keep moving to each E point. And also you can go little outside to see that your lines are not like vertical. When it go outside, they are curving. So maybe you can take around 1 point outside from the plate. Okay, so now you can connect those. Almost a vertical line, but little bend when it closer to the endings. Okay, so now you move into the E2 and repeat exactly the same thing. Is that the last one?
Yes. Sorry.
Okay, good. So now we'll measure the voltage of each line as we did earlier. So keep the your eye on the horizontal line, and then we're going to remove the E7 cable and connect that into the red. And then we're going to measure the voltage of each line on that horizontal line. You have it in your mind. Okay, so first one 1.08. 2.20, 30, 3.70, 5.10, 6.41, 7.54, and last one 8.34. Good. And now you're going to take the black from the probe out, and then you're going to measure the whole voltage to the black. 9.40. So now let's input those into the Excel sheet. So that will be this number. Okay, so now distance again, everything around 1 centimeter, so we can use 1 centimeter. Usually we need to measure them, but since they are around 1 centimeter, we can use those values. Meters, and potential on the first line is 1.08, 2.30, 2.70, 1 is 5.1, 0.41, 8.3. And total voltage we supply is 9. Good. Okay, so now let's disconnect the circuit and do the rest of the calculation. Disconnect the circuit. You can switch off the power first and then unplug it. I'm going to leave it as it was for the next group. And now make sure your voltage, yeah, that's enough, I think. Yeah. So now rotate your voltage knob to the all the way counterclockwise. Just leave it there, that's fine. Did you complete the voltage? Okay, good. So now you can disconnect these wires. and make sure that you take the parallel plate out. And you need to put that into the correct envelope. And then we can leave the probe on the table and disconnect other things and make sure voltmeter is off. You can make it vertical like this, right, and switch off it. If you can make the cables as you found. Sometimes it is very hard to do that way, but you can try your best.
Excuse me, Professor.
Yes, go ahead. What?
Class is finished.
Yeah, we finished it, but you have some other calculation to do in your double equation.
I'm sorry. I'm sorry I didn't hear you. Could you repeat, please?
Experimental data collection is done, but there are some calculation you have to do in your double equation. I'm going to finish up with this table, then we are done. Resting for you. Okay, so now we're going to calculate the electric field, and to calculate the electric field, we're going to use the electric field equal delta V over, dx, dV over dx. So basically delta V over delta x. So to calculate that, we're going to go over here and type equal. You're going to take the potential difference. So you have this potential minus the other potential you have, and then you're going to divide that by the 1 centimeter. 1 centimeter equal 0.01 meters, right? So we need to convert into meters. Because of that, you're going to type 0.01 in. So that will give you the electric field. So this will be one of the double equation, I think W4 or something. So, but you can calculate it here and use it for your lab report. Okay. And now from the Excel, we can easily calculate the rest of the electric field by choosing correct preference for each cell, right? So if you go to this cell, if you bring your cursor closer to the right bottom corner on the calculated cell, you will see that kind of like black plus sign will open. And then you're going to drag that one all the way down, then it will calculate the rest of the electric fields for you. So usually this electric field should be a constant, but you will see the variation because of our experimental issues that the probe is not correctly touched. Maybe it has some fluctuations. Because of that, you may not get exactly the same number, but theoretically these numbers should be the same. Okay, good. And so now we need to calculate the average E here. That's one of the W questions too. You can type the average, and then you're going to select the range you need to average, and that will give you the average in the Excel. So I'm copying the equation on the side. If somebody is struggling with that, you can try it yourself.
Could you repeat the experimental uncertainty, please?
Where is the experimental uncertainty?
No, sorry. You said the
Read the W question yourself
fields
and answer to those questions.
The fields should be the same, and the fields are the same here. You were given the reason why the number for the fields aren't the same.
Why do you think they are not the same? Why do you think? What do you think about that? You need to answer yourself. You have seen the experiment. So when you do the experiment, you have some experimental errors, right?
Okay.
So you need to think about what we did, and you use the probe. So probe, when you use it, if you not correctly touch them together, it will not give you exactly the voltage we need. Because of that, sometimes it may not be the zero position. Because of that, you may have some fluctuations.
Okay. Thanks.
So for the other applications, you guys going to answer those. Basically, it's asking some conceptual numbers. Okay, anybody else have any other questions?
Yeah, I had a question.
Yeah, go ahead.
So for the field section on the right, I got the first one for the 2 centimeter distance, but how did you like drag it down to get all of the other?
Okay, so that will be very simple. Let me clear the content. So if you go in here, so you calculate, you get the 122, right?
Yeah, I got that.
After that, you bring your mouse, this bottom corner of that cell, you will see that it like big plus sign, like hospital sign, and then when you bring it very closer to the bottom right corner, you will see your sign is changed.
Yeah.
Then you click and drag.
Oh, okay, and then it'll calculate everything else.
Yeah. Good.
Okay. Yeah. Thank you.
Mm-hmm. If you have no questions, you can leave. I can see you guys next week.
Thank you.
Have a great